All right, guys, we're going to work on lesson 5.6 today, which are inverses of linear functions. This is going to be the last section we cover in this module 5. So at the end of the week, we're going to be ready to take a quiz. But there's going to be a little bit of work here. The homework assignment tonight isn't real long, but there is some detail to it that just a lot of little things that we need to make sure we go over and you, excuse me, and you understand. Okay, first of all, this concept of inverses, what are we talking about? Well, if you think about inverses, inverses are operations that undo one another. For example, the inverse of addition is subtraction, the inverse of multiplication is division, because those undo each other. For example, you start with a number 5. If you add 2, you get 7. If you subtract 2, you're back to 5. So the adding of 2 and subtracting of 2 undid one another. So we're looking at now, we're expanding that into the concept of functions. How do we undo a function? All right. And we start looking at inverses of these functions. Well, the first thing we're going to do is look at the inverse of a relation. Okay. Two relations are inverse relations if and only if one relation contains the points in the form AB, then the other one contains the points in the form BA. So what happens is, in short, the x coordinates and the y coordinates are exchanged for each ordered pair in the relation. Okay. So for example, if this was relation A, and what this shows is a mapping, right? The input of 2 has an output of 3. The input of 4 has an output of 5. The input of 6 has an output of 7. Okay. The inverse of that relation would be the relation that looks like this. We'll call it relation B. An input of 3 has an output of 2. An input of 5 has an output of 4. An input of 7 has an output of 6. So I've interchanged the inputs and the outputs of the domain and the range, or the X's and the Y's, however you want to look at it. I interchanged them. And the whole idea is that we create an inverse. A and B are inverses of each other. Okay, so if you look at relation A, if I input 2, I get an output of 3. Now, if you move into relation B, the output of 3 gives you an input of 2. So that undid, if you will, relation B undid relation A. An input of 2 gave you 3, and then you go to B, input of 3, you're back to 2. So it's like they undid each other. All right. So every input in relation A, the inverse relation B will undo that process and go right back to the original value. Kind of like the opposite of addition is subtraction and so forth, but now we're doing it a little differently. Okay. Now, the idea of a one-to-one function, you're going to see that in tonight's homework. And all that means is a function is a one-to-one function if no two different elements in the domain have the same element of the range. Now, if you think about our function rules, every input has to only have one output. It never ruled out a bunch of inputs having the same output. Okay, you could have an input of 1 match with the 1, 2 match with 1, 3 match with 1. You keep doing that, and it was okay for a function, but that's not one to one. Okay, one to one means you don't have an input value paired with, you know, two different, I guess, outputs paired with the same input. Okay, in other words, no input is paired with the same output. Everything's unique. All right, so it's a little more restringent. Okay, we're not going to do a ton with that. I just wanted to mention it to you so when you see it tonight, you don't wonder what the heck's going on. All right, how do we find the inverse of a function? Well, we're going to start with finding the inverse of a function that's given to us as a set of ordered pairs. To be able to write the inverse of a set of ordered pairs, we simply rewrite it with the x and the y coordinates interchanged. In other words, we're going to interchange the domain and the range. So let's say we were given function g. Okay, g is a function that has this set of ordered pairs: negative 2, 3, 4, negative 5, 0, 8, 7, negative 9. Okay, the inverse of g, which we write like this: g to the negative first power. That's the inverse of g. The inverse of g is a collection of four ordered pairs with each of the ordered pairs reversed. So negative 2, 3 became 3, negative 2. 4, negative 5 becomes negative 5, 4. 0, 8 becomes 8, 0. 7, negative 9 becomes negative 9, 7. They undo one another. Okay. And then they can even ask us about function values of these. So for example, g of negative 2. All right. So let me get my mouse where I need it here. Never find it. Okay. G of negative 2. Go to the g function. Input of negative 2 has an output of 3. So g of negative 2 is 3. What's g of 7? Well, g function. X value, input of 7, output is -9. What's G inverse of 3? So G inverse function, input of 3, has an output of -2. The G inverse of -9, all right, input of -9, output of 7. Okay, so we look at it that way when we want to find function values. We don't have to calculate the answers are given to us. There's the input -2, there's the output 3. That's the answer when you input it. Okay, so that's one way we can find inverses. A second way we can find inverses of actually be given a rule, a linear function. All right, so to find the inverse of a function when it's written in function notation, then we have to follow these steps. And you're going to want to write these down and follow them. Step one is replace f of x with y in the given function. Step two, interchange the x and y in the function. Step three, solve the equation for y. The new equation that you get in step two, solve that for y. And finally, replace y with f inverse of x in the new equation. When you're done with that, you have the inverse of that function. Your new one, your inverse, will undo your old one. And let me show you how it works here. Okay. All right. So find the inverse of this function. F of x equals -3x plus 27. So this function, -3x plus 27, if you put an input in there, you'll get an output, input, output, input, output. We want to write a function that will undo all those. All right. So here's how we do it. Start with f of x equals -3x plus 27. That's given. Replace f of x with y. Step two, interchange x and y. So I'm going to actually switch the x and y positions. I'm going to make it x equals -3y plus 27. Now solve that for y. Subtract 27 from both sides. Okay, x minus 27 equals -3y. Divide each side. Well, actually, I interchange the two sides now. So I always like to have what I'm solving for on the left. So -3y equals x minus 27. Divide everything by -3. Okay. And then if I simplify that, you don't always have to, but I'm going to simplify it and write it as y equals -1/3 x plus 9. Remember, when we divide by the -3, we're dividing the x by -3. Remember, there's a 1 in front, so that becomes -1/3 x. And then -27 divided by -3 is +9. Okay, so that's how I simplify that. And now the last step, when I'm done solving for y, is replace y with f inverse of x. F to the -1 of x equals -1/3 x plus 9. Okay? So that function is the inverse of the f of x function. Let me show you what I'm talking about here. Let's say I took my original function and I want to find the function value of 2. So what's f of 2? So f of 2 says go to the f function and put 2 in place of x. So that's -3 times 2 plus 27. That's -6 plus 27. That's 21. So in my f function, an input of 2 gives me an output of 21. So what should happen is if I take my f inverse function and I input 21, I should get an answer of 2 because it undoes that. So what's f inverse of 21? Well, take your f inverse function that I have down here and replace x with 21. So it's -1/3 times 21 plus 9. -1/3 times 21, excuse me, is -7 plus 9. Oh, sorry, that should be +2. Okay. So an input of 2 in the f function gave me an output of 21. An input of 21 in the inverse function gives me an output of 2. So it undid it. Okay. So I started with 2 and my inverse undid it and gave me 2 back. That should be +2. So that's what we're talking about with the concept of an inverse function. Okay. All right. Now you're also going to see something today that's called a composition, a function composition. Kind of a fancy looking expression, but I'm going to just show you simply what it means. All right. Let's say I gave you these two functions, f of x equals x plus 3, and the inverse of this function, f inverse of x, is x minus 3. Okay. Now let me show you how a composition works. It's going to be written like this. What we say is, what is f of the f inverse of 5? Okay, so what that means is you want to find the function value of the answer to f inverse of 5. I want to find the f function value to the output answer of f inverse of 5. So basically, we're going to solve this like we do any parentheses. We're going to go inside out. So what's f inverse of 5? We'll go to the f inverse function and replace x with 5. Okay, so I'm going to find f of 5 minus 3, f of 2. Okay, so now I'm going to go to the f function and put 2 in place of x, and f of 2 is 5. So f of f inverse of 5 is 5. So what we're trying to show you here is if you do the function of the inverse, you should get the original input number back. Okay, because an inverse undoes the function. But that's how we say it. So let me show you another one here. Let's go f inverse of f of -7. Now these two are inverses of each other, so one should undo the other. So the way I have this one written is we're going to find f inverse of f of -7. So go to the f function and put -7 in place of x. So now we're going to have f inverse of -7 plus 3. -7 plus 3 is -4. F inverse of -4. So go to the f inverse function, put -4 in place of x. We get -4 minus 3, which is -4 plus -3, which is -7. So f inverse of f of -7 is -7. So again, a function and its inverse, they undid each other. I got my original value back, and that's what should happen. All right, let's take a look at what homework's going to be like tonight. You're going to have 5 questions that look like this. Okay. So the one-to-one functions g and h are defined as follows. I talked to you a little bit about one-to-one means. It's not going to impact how you do the problem. So they're giving me the g function as a list of ordered pairs. Okay. They're giving me the h function as a rule. So it's a written as an equation rule. So they're asking me to find the following. What's g inverse of 7? What's h inverse of x? And what's h of h inverse of -1? All right. So the first thing I want to do is find the inverse of each function. So how do we find the inverse of the g function? Well, we just relist it, g inverse of and we switch the x and y ordered pairs. Okay. Switch all the ordered pairs. All right. Now I might as well answer this. What's g inverse of 7? So go to the g function. An input of 7 gave us an output of -8. So the g inverse of 7 is -8. There's the first part. Second thing they want me to do is find h inverse of x. So they want me to find the inverse of this function. So h of x equals 3x minus 13. Let's go through our inverse process. Replace h of x with y. Interchange x and y. Okay, let me get out of here. Sorry. Interchange x and y and solve for y. So add 13 to both sides. Switch sides. Divide both sides by 3. And we get y equals x plus 13 over 3. I'm just going to leave it like that. All right, that's fine. We can leave it like that. I could try to simplify each term, but I'm not going to. The last part of the process, remember, is replace y with h inverse of x. Okay, so that should have a h inverse of x. I should have x in parentheses after that, but I don't. So h inverse is x plus 13 over 3. I'm going to write that over here, x plus 13 over 3. And then they want me to find h of h inverse of -1. All right, so I'll go through that. H of h inverse of -1 means find h of h inverse of -1. So find h inverse of -1 first. Okay, so that means take your h inverse function, put -1 in place of x. -1 plus 13 is 12. 12 divided by 3 is 4. So h of 4 now. So go to your h function, put 4 in place of x. 3 times 4 minus 13. 12 minus 13 is -1. Okay, so h of h inverse of -1 is -1, and that's what should happen. Okay, let's do another one of those. Okay, so there's my g function given, there's my h function given. They want us to find g inverse of -3. They want us to find h inverse of x, which is the inverse rule, and then they want us to find h of h inverse of -8. Okay, start by finding the inverse for each one. So the inverse of the g function, when they give you a list of ordered pairs, you find the g inverse by interchanging the x and y's. And then they want to know what's g inverse of -3. So go to the -3 input. -3 is an input. I get 5 as an output. So 5. Easy enough. Okay. Now find h inverse of x. We'll start with h of x. Replace h of x with y. Interchange x and y. Okay. Solve for y. I'm going to add 2 to both sides. Interchange the sides. Divide both sides by 3. And I'm going to leave it like that. And then the last step is to replace my y with h inverse. So the h inverse of x function is x plus 2 over 3. Go over to your answer and put that in. Okay. Now you might be able to simplify in some different ways, and I'm sure it'll accept it, but that's all. That's all we really need. And now it wants us to find h of h inverse of -8. We should get -8 as an answer to this. So h of h inverse of -8 is asking us to find the h inverse of -8 value, and then take that answer and put it in the h function. So h inverse of -8. So we're going to go -8 plus 2 over 3. -8 plus 2 is -6. -6 divided by 3 is -2. So I want to find h of -2. Go to the h function, put -2 in place of x. 3 times -2 minus 2. That's -6 minus 2, which is really -6 plus -2, which is -8. And we should get -8 because it inverse undoes the function. Okay. So those are the types of questions. You're not going to get a ton of them, but you want to write it down, be organized, take your time with it, look at examples. If you need to pull up some other examples, Alex will have them there for you. All right. But I'll let you get at your homework and make sure you get those done for tonight.